this video I would like to explain about series and parallel combinations of resistors, capacitors and inductors that are frequently used in solving the linear or complex electric circuits. So the topic for today is series or parallel combination of resistors, inductors and capacitors. So first of all we have to understand about what is series combination and what is parallel combination. This is our first step. Next step, how to solve the series combination of resistors. In next step, how to solve series combination of inductor. In next, how to solve series combination of capacitors. Furthermore, we will discuss about the parallel combination of all these three passive components: resistors, capacitors and inductors. So what about series? As you have seen in daily life that series of event is occurring one after another, one event occur and after an event is occur, event 1, event 2. This is series of events occurring one after another in our daily life. This is series. And in parallel, two or more than two events occurring in parallel. In parallel mean this is one event and this is another event and this is another event. In parallel, 1, 2 or 3 events are occurring in our daily life. Now in analogous in electric circuits, how these will behave like, see here, assume these are resistors and this is its start point and this is its end point. Okay, I can rename its resistor R1, it is start 1 and start 2. It is and 1, sorry, it is resistor R2, its start is S2 and its end is E2. Similarly, S3, E3, S4, E4, R3 and name it R4. So see here, start of a resistor is joining with end of another resistor, or end of a resistor is being connected at start of another resistor. This is the series combination. For example, you can make here, these are three resistors are connected here. Anything else is nothing connected here. Just at initial stage I am explaining you how these resistors are connected with each other. So see here, this start of one resistor, this is end of another resistor, this is start of another resistor, this is end of it is start of it and it's end of it. So start and end are connecting with each other. So these resistors will be in series here in this circuit. Okay, this is the more basic point how the resistors are connected in series. Now in parallel, see here, this is start, this is its end. Okay, this is start, this is start, this is their end, this is their end. Start of resistor is connected with end of another. Starts are common, ends are common. It means these are in parallel with each other. These are at basic stage how the resistors are connected in series or in parallel. So we will evaluate these circuits by connecting with source. See here, this is my voltage source, DC voltage source. This is my resistor 1, this is my resistor 2, this is resistor 3, this is resistor 4, this is resistor 5, this is resistor 6, this is resistor 7, this is resistor 8, this is resistor 9. So how can I analyze that which resistor is connected in which configuration? See here, starts and ends are connecting with each other. So 1, 2, 3 resistors are in series. Their whole combination, assume here from here to here, their whole combination here will make a one resistor. This resistor will be in parallel with this resistor. Their combination will make another one resistor that will be here. Okay, this resistor will be in series with this resistor because this will be vanished now. These will have start and end with each other. Now we will solve this stepwise and we will understand how it's working. See here, it is R1, R2, R3, R4, R5, R6, R7 and R8 with R9. Now how we will solve it? We will always solve from right to left, from load end towards source end. It's my load end, it's towards source end. We will solve it. So I can rename it R123. R1, 2, 3 will be equal to R1 plus R2 plus R3. It is my one resistor. R1 to 3 is equal to series combination of three resistors. So I will have only one resistor at this terminal. R1 to 3 I will have an equivalent resistor of R1 to 3. Now here you can see R1 to 3 is in parallel with R14. So calculate its equivalent resistor and rename it. R1 2 3 4 will be equal to R1 2 3 in parallel with R4, which is equal to R1 2 3. R4 divided by R1 2 3 plus R4. This is the formula for parallel combination of solving it. So their parallel combination will make here another resistor. So remove this, reconnect another resistor here. This will be R1 2 3 4. Now see here, R1 2 3 4 is making joint with this resistor. Its end is connecting with start of this resistor. This will make another resistor of series combination. So here I will have another resistor. R1 2 3 4 5 will be equal to R1 2 3 4 plus R5. This is my R1 2 3 4 5 resistor. This will make another resistor which will have start here and end is here. So I will connect another resistor here. It is R1 2 3 4 5. See here, this resistor, these three resistors are in parallel. These will make an other single resistor that will be connected here. That single resistor will be in series with R8 and 9. So how I solve these three resistors in parallel combination? Make an equivalent resistors are named R1 2 3 4 5 6 7 will be equal to R1 2 3 4 5 in parallel with R6 in parallel with R7. So how will I solve these things? You can see here 1 over R equivalent in parallel is equal to 1 over R1 plus 1 over R2 plus until 1 over Rn. Okay, so solve here in this combination. It will be equal to R1 R2 R3 R4 until Rn. This will be their LCM, and here is R1 is cancelled out. The remaining R resistors will be here, R2 R3 R4 till Rn, plus R2 will be vanished here, R1 R3 until Rn, and similar behavior of R resistors is occurring. Now at next step 1 over R equivalent will be here, and how to solve R equivalent? R equivalent will be on upper direction and this will be switched on upper. R equivalent will be R1 R2 R3 so on Rn, its multiplication divided by their HCF. So R5 R6 and R7 will be solved here. 1 over R1 2 3 4 5 6 7 is equal to equivalent resistance is equal to 1 over R1 2 3 4 5 plus 1 over R6 plus 1 over R7. Now solve it. Here you will get here R1 2 3 4 5 multiplied with R6 multiplied with R7. Here it will be R6 plus 7, R6 R7 plus R1 2 3 4 5 R7 because it's R6 and R1 2 3 4 5 R6. It will be 1 over R1 2 3 4 5 6 7. So switch it or flap it, it will be in numerator and it will be in numerator. So R1 2 3 4 5 6 7 will be R1 2 3 4 5 6 7 will be equal to product of the resistors R1 2 3 4 5 R6 and R7 divided by R6 R7 R6 R7 plus R1 2 3 4 5 R7 plus R1 2 3 4 5 R6. This will be until here at this point. Okay, so remove these resistors and connect another resistor here R1 2 3 4 5 6 7. So it is here. So see here, it's the series combination end of start and start and start with end. Okay, so add them all the resistors, you will get the equivalent resistor. R equivalent will be equal to R1 plus R2 plus R8 plus R9. It's my R8 plus R9 plus R1 to 7. Okay, this will be addition of error. So R equivalent will be equal to R8 plus R9 plus this is here R5 R1 2 3 4 5 R6 R7 divided by R6 R7 plus R1 2 3 4 5 R7 plus R1 2 3 4 5 R6. It will be my equivalent resistor. Go back and put value of R1 2 3 4 5 6 here and you will evaluate the final resistor. The main purpose of this evaluation is how to solve the series or parallel combination of resistors. Till now I have explained about the series and parallel combination of the resistors. Here in next step I will elaborate this thing by giving many examples about that and tricks to solve that resistors. We will quickly go through that and let me explain you how extent you have learned here. See here, it's my source, this is my resistor, this is my resistor, this is my resistor, and this is my resistor, and this is my resistor. Okay, this is R1, R2, R3, R4, R5. So how these resistors are being connected here? See here, at first step I have to evaluate from load end towards source end. See here, two resistors have one common point and two distinct points. This is another way to get them. Two or more than two resistors have one common points and others at a distinct point. This will be at series because it's end at start here. So R1 and R2 will be in series. R12 is equal to R1 plus R2. Their whole combination is making another resistor which has start here and end at here. So that resistor will be connected here. That will be in parallel with the series combination of R3 and R4. So how I will evaluate? Just remove that. Another resistor is connected here. This is R1 2. So see here, you can just reshape it. See here, both resistors have one combined point and another combined point. This means their series combination, because these have one common point and two distinct points, This will have series combination, their whole will be in parallel with R12. So rename it in series, that will be here R34. R34 will be equal to R3 plus R4. So R34 and R12 will be in parallel. R34 in parallel with R12 will be equal to R34 R12 divided by R34 plus R12. So R34 R12 their parallel combination is here. So you can rename it R1234 R1234 sorry R1234 will be here. Their parallel combination will make an other resistor. Just connect single one resistor here. So connect a single one resistor here R1234. R1234 will be in series with that circuit. So add both the resistors, you will get R1234 5 is equal to R1234 plus R5. Just put the value of R1234 here and you will get the result here. Now another interesting point here is that the parallel combination is solved directly by formula, but in previous I have explained that you can solve it R1234 in R1234 in this manner. 1 over R1234 is equal to R12 plus 1 over R34. Just solve it, you will get R12 R34 here. At above you will get R34 plus R12 1 over R1234. Just swap it, you will get the R1234. Numerator will become denominator and denominator will become numerator. R1234 will be equal to R12 R34 divided by R12 plus R34. That was in shortcut here. So this is the simple one, series and parallel combination of resistors. In next sessions I will evaluate about series and parallel combinations of inductor and capacitors with more detailed examples. Thank you.